Alrighty, 3.4. Solving quadratic equations by factoring. Most of these you've done before, okay, which is the nice part. Some of them you have not, which we got to work on. Alright, but most of them you've done before. Thank you, sir. Okay, so you really don't need the top box, okay? The top box explains foiling, which you already pretty much know how to do first. Outer, inner, glass. Okay, no big deal there. You know how to do that. The bottom box, though, you do kind of at least need to be aware of. It's not really something you need to write down. It's one of the most, how do I want to word this? Most useless, important properties you ever write down. Which sounds oxymoronic, doesn't it? But it's true, okay? It's called the zero product property for any real numbers A and B. If A times B, now listen to this part. If A times B equals 0, then either A is 0 or B is 0 or they're both 0. Make sense? Right? If you're multiplying two things together and they equal 0, either one of them are 0 or both of them are 0. It's like the only way you're going to multiply to get to 0, right? I mean, we've learned this, what, 3rd grade? Okay? Anything times 0 is 0. All right? That's cool. That's the easy part. That's where the useless part comes in. Where the important part comes in is solving it then. If x plus 3 times x minus 5 equals 0, using the same logic now, then either x plus 3 equals 0 or x minus 5 equals 0. One of the two. Okay? One of the two. Where that comes into play for us is whenever we go to solve. So your goal today is going to be to factor things to get a multiplication amongst them so you can split them up and then solve them. Okay, now, two different types of problems. All right, most slides today will look like this. Okay, most slides. One side will say factor, the other side will say solve. And there's a big difference between the two. One side will say factor, one side will say solve. Now, if you look at the questions or the polynomials, what's the one thing you notice that's different from left to right? The one on the right equals 0. Everybody see that? That's an equation, right? Because it's got an equal sign in it. Okay? And when you have an equation, typically you solve for the variable that you're missing, in this case, x. The left one doesn't have any equals. That's why it just says factor. And that's it. Okay? So, today, throughout, we're going to learn all different, or review kind of all different types of factoring that you've done. Okay? The first one being this. Now, I'm going to write down an M and an A. Let's see if that joggles some memories. Anybody remember what M stands for in this case? It's been a while, so if you don't, that's all right. No. Multiply. Okay. Specifically, multiply number. Okay. And in this case, the multiply number is 20. All right. Where do you think I got that from? Right there, from C. Okay. Now, A is what they call your add number, and your add number in this case would be, what do you think? 9. Very good. Okay. From here. All right. Okay. Now, remember that first box I said don't write down because it's FOIL and you know how to FOIL? Remember that? Okay. What factoring is unfoiling, basically. It's a lot like dividing. You're unfoiling trinomials. So there was two binomials somewhere along the way that you could FOIL together to get x squared plus 9x plus 20. Okay, now think about how FOIL works. Your first is your first times your first. typically x times x, which gives you x squared. Go to your last. Your last is a number times a number, and those two numbers give you usually the n number. In this case, it's 20. Your middle two you always do what with? Starts with a C. CLT. Combine like terms. So those two numbers had to add up to equal the middle, which is 9. So in this case, you're going to turn that trinomial into two binomials. That FOIL back to that. That's a terrible FOIL. There we go. So you need to figure out what two numbers multiply to 20 and add 9. 5 and 4. 4 and 5. Whichever way you want to do it. X plus 4. X plus 5. Okay? Those two FOIL back to x squared plus 9x plus 20, right? X times x, x squared. X times 5, 5x. 4x times 5 is 4x. 5x plus 4x. 9x. 4x times 5, 20. Okay? Here, I'll show that work here. Pull up. See, look at that now. Yeah, same thing. Okay? That's the key. That's the goal. Okay? Now, the other part of this you have to pay attention to is that whether they specify to factor or to solve. Factor, those are your answers right there. Do them in green. So that way they stand out. Look at them standing out right there. Ooh, pretty. Okay? When you solve, you do the exact same things. Okay, your multiplying number is 20. Your add number is 9. Your two factors are x plus 5, x plus 4. But this time they equal 0 now. Okay, and remember what that zero product property says. If A times B equals 0, either A is 0 or B is 0. In this case, x plus 5 is acting like A, x plus 4 is acting like B, and they equal 0. Which means you can then take this part, x plus 5, and that equals 0, or x plus 4 is equal to 0. You can split them off into two and turn it into two very simple solves. X plus 5 equals 0, which means x equals -5. X plus 4 equals 0, which means x equals -4. And those are your two solutions. So notice the difference. These are factor. Those are your factors. The binomials are your answer. When you solve, x equals are your answers. Okay, so the first one we said we got to multiply number of 40, add number of 13. So whenever you're doing these, go through the numbers that multiply to 40. Okay, don't go through the numbers that add to 13. There's plenty of those. Okay, go through the numbers that multiply to 40 first. Okay, 1 and 40, 2 and 20, 4 and 10, stuff like that. Okay, what am I missing? 8 and 5, is that right? Yeah. Okay, stuff like, and then that's it. And if you need to write them over to the side, do so. All right, that's no big deal, no shame. Okay, if you got to go through like that. But go through that list first, because that list is going to be what, at least that's going to narrow down the possibilities of these numbers, right? If you go through the numbers that add to 13, you're going to be sitting there all day. Okay, so be aware of that. All right, so two numbers, multiply to 40 and add to 13. What are they? 5 and 8. Good. x plus 5, x plus 8. If you're ever unsure, FOIL it back through. Okay, that's how you double check it. Split it off now. X plus 5 equals 0. X plus 8 equals 0. So x equals negative 5. And x equals negative 8. Well, that was a terrible 8. Let's try that again. Hey, there we go. Notice how I set that up right away. Didn't even ask you guys a question, didn't even say nothing. It's always going to be x first, right? Or whatever variable's there. X, v, z, whatever the case is. So in this case, your multiply number, negative 35, and your add number is negative 2. Good. So this one you have to be careful with, okay? Now, think about this for a split second. If your multiply number is a negative, and you're multiplying two numbers together to get that negative, one of them has to be what? One has to be what? Very good. So that also is going to correlate in your signs in your binomials. One's plus, one's minus. Automatically. So if your multiply number is negative, those two signs in the middle are one's plus, one's minus, automatic. Now, what are those numbers? Just the numbers, not the signs. Numbers are 5 and 7. All right, 5 and 7. Now make your signs work. Which one's positive, which one's negative? 7 is negative, 5 is good. Okay? Remember, look at this sign here. The bigger one needs to be this because you add them together, right? Negative 7 plus 5, negative 2. Ms. Peterson.
How did you get 5 and 7?
They multiply to 35, right?
Oh.
Okay. And then whenever you add them up, whenever one's positive, one's negative, negative 7 plus 5, negative 2. Okay. It's really kind of, it's not, it's really kind of like a matching game. There's really not a whole, it's the whole math part of it's not really too hard. Your numbers will be somewhat tamed. It's more so just understanding the parts of the process where they go. Your numbers aren't going to be huge. Okay. But you have to understand what you're trying to do. Okay. Split them off. X plus 5 equals 0. X minus 7 equals 0. X equals negative 5. And x equals 7. Here comes the sun. Da-da-da-da-da. I know, I'm pretty. I got a pretty voice. I can sing. I should join the choir. Yeah. Yeah. I got it. I can nail it. Sing so pretty. Okay. Now, first one, multiplied number in this case is what? 64. Add number is 16. So you go through your brain, you're like, okay, two numbers, multiply to 64, add to 16. And 8. 8 and 8. Equals 0. 8 and 8. Right? 8 times 8, 64. 8 plus 8, 16. Fantastic. Split them off. Subtract them over. Both times you're going to get x equals what? Negative 8. Other side. Okay? Okay. Now, if you notice that they're both x plus 8, x plus 8, if both times you're going to get negative 8, you don't need to write it twice. Okay? Everybody see that? Both times you're going to get negative 8, so you only have to write it one time. I don't care to see it twice. Okay? But make sure you do, if it's not the case, make sure you split it off twice, if there's anything else. Okay? Does that make sense? Does anybody know what, pay attention to that factoring, x plus 8, x plus 8. Does anybody know what this trinomial is called? 3 words, first one's a P. Starts with a P. Last word is trinomial. Perfect square trinomial. Brown for the W. Okay? Perfect square trinomial. They call it that because you have the same factors both times. See that? Okay? So your telltale sign of this is if your multiply number is a perfect square. 64, 25, 49, stuff like that. That's your first clue. And then if the middle one is an add number of those two numbers added together, that's what it will be. Okay? You don't need to know all that because you guys did it with just going the exact same approach. Multiply number, add number. You'll figure it out the exact same way. Okay? All right, the next one. X squared minus 64. What's my multiply number? Sign. Negative 64. What's my add number? Huh? It don't exist. It don't exist. 0. Stop hating on 0, Booker. Don't cramp up either. Was that what that was? I thought you said Branson. No? You good? Okay. No cramps. Okay. So now you go through the same way. What two numbers multiply to negative 64 and add to 0?
8.
And?
8.
8 and negative 8. See that? X plus 8. X minus 8. Now, this one you will get two different answers. So you got to split it and do it twice. Alright, so X plus 8 equals 0. X minus 8 equals 0. X equals negative 8. X equals positive 8. Okay, because once again, FOIL this out. X times X is X squared. X times negative 8, negative 8X. Positive 8 times X, positive 8X. Those two add up to be 0, right? 8 times negative 8, negative 64. So this is a funny looking guy. Okay, he looks weird. Take him the exact same way. Okay, exact same way. Alright, new one. I don't think you've seen this before. Okay? For lack of a better name, because I really don't know one, and this came from a professor of mine, it's called bottoms-up factoring. Yes, make as many jokes about that as you want to. Okay? It's called bottoms-up factoring, and you will see why. Alright? It's still a trinomial, right? Everybody see that? Still three terms on the left. So you're still going to do it the exact same way. You're going to look for a multiply number. You're going to look for an add number. Alright? Here's the problem, though. Every math teacher, including me, because I didn't tell you this ahead of time, so I'm just as bad as the rest of them, I guess. Every math teacher you probably had in your life has been lying to you whenever it comes to this type of problem. Any trinomials. Okay? Your multiply number in this one is not negative 15. Your multiply number in this one is, I believe, 180. Let me make sure I have my math's right this morning. Yes, actually negative 180. Does anybody know how I got negative 180? Multiply what? 12 and negative 15. Your multiply number is, will be, and always has been A times C. From your standard form, right? AX squared plus BX plus C. Always has been. Up to this point, A has always been what? 1. So it hasn't mattered. Okay? Your add number, still B. So negative 8. That doesn't change. Okay? So here's where this gets a little messy. Now you need to think of numbers that multiply to negative 180 and add to negative 8. Alright, so we have x's here and here. Since their multiply number is negative, that means 1 plus, 1 minus. And what two numbers multiply to negative 180, add to negative 8? positive 10, negative 18. Okay. Now, that used to be a completed problem and used to be done. Now you're not. Because this obviously does not FOIL back to 12x squared minus 8x minus 15, right? Okay. So here's where the craziness begins. Ready? A is 12. That 12 is what has been throwing our problem off. So you work with it. What you do is you take that 12 and you put it underneath your 10 and your 18. You just created two what starts with an F? Fractions. And fractions we know can what? Reduce. So reduce them. Okay. X plus 10 twelfths reduces by 2, 2. I said 2, 2. 5, 6. X minus, now 18 twelfths reduces by 6 to what? 3 over 2, very good. Which still doesn't get us where we want to be. Okay? Which is where the name comes into play. What's it called? Bottoms up factoring. Take the bottom and you move them up. 6x plus 5. Whoops, stray mark. 2x minus 3. That was a terrible 3. Let's try that again. It's a little better. FOIL those out. Watch my finger. 6x times 2x. 12x squared. 6x minus 3, negative 18. 5 times 2 is 10. Negative 18 plus 10, negative 8. 5 times negative 3, negative 15. Finished product. Right there. Bless you. Okay, back to algebra. Now, notice how the left one is just factor. The right one is an equation where we solve, right? Okay? Same steps. Okay, same exact steps, so I'm going to pick it up from where we left off the last one. So 6x plus 5, 2x minus 3 equals 0. You clean this one up the exact same way. You split them off into 2. Okay, 6x plus 5 equals 0. 2x minus 3 equals 0. The only difference here, these could be just two-step solves instead of just one-step solves. Okay, that's the only difference. Okay, earlier we had one step where you just moved one number over. Here we have two where you got to move the number over and then divide. Okay. So your first one here, we're going to subtract 5. So 6x equals negative 5. Divide by 6. X equals negative 5 sixths. The second one, add 3. 2x equals 3. Divide by 2. X equals 3 halves. And there's your two answers. So we got your multiplied number being 180. Add number, negative 23. Okay, so we talked about, there's a lot of, there's sign rules to this, okay? I just kind of like, I don't make you guys memorize the sign rules. I kind of just say, you know, just play with the numbers, figure it out, right? Like for the instance, if it's going to multiply to a positive, add to negative, they're both going to be negative. Okay? So what two numbers, you know, multiply to 180, add to 23, Mr. Taylor? Negative 8, negative 15. Okay. It's a long road to get to 8 and 15 when you go up by twos, but you do eventually get there. Okay? And that's the only bad part about these types of problems. It could take you a little while to get those numbers right. Okay? Do your bottoms up part. We're going to divide each one of these by what? Taylor? 6. Good. And then we have fractions to reduce. So x minus each of those by 2 to give you 4/3. X minus each of these by 3 to give you 5/2. So equals 0. Okay. Do your bottoms up step. So 3 up and 2 up. So 3x minus 4 times 2x minus 5 equals 0. I'll move it up here to split them off. 3x minus 4, that was terrible 4, equals 0. So you add 4 and divide by 3, so 3x equals 4, x equals 4/3, there's 1. Your other one, 2x minus 5 equals 0. 2x equals 5. X equals 5/2.